Okay, guys, there are 2 lessons left in Chapter 12 for us. We have Lesson 8, which is solving general triangles. And what we're going to do is we're going to take the law of sines, the law of cosines, and we're going to wrap it up to take care of any triangle that we may have. So, the problem of solving triangles can be divided into 4 cases. There are 4 different situations that we will see and we can solve. So, there is side, 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 meaning that they give us 3 sides. We can solve the triangle from that. Side, angle, side, meaning they give us 2 sides and then the angle between them. Side, side angle, which means they give us 2 sides and then the angle across from one of them. That's different than side, angle, side. And then angle, side, angle, or angle, angle, side. So that's 2 angles and then 1 side. Okay, now if you did geometry with me, you remember that side, 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 angle, side, angle, and angle, angle, side are used in geometry to prove that triangles are congruent. So there's a lot of overlap here. But if you know 2 sides and an angle that's not in between them, it's not enough to prove the 2 triangles are congruent. And later in this lesson, it's actually going to cause some trouble as well. So side, side angle is troubling. Okay. Let's go through the first example. We're going to find any angle measurements or links to 3 significant digits. Okay, so here's the first case, a side, side, side case. Now, in a triangle ABC, if the side is 4 and the other side is 6 and side C is 5, solve the triangle. Okay, we're going to use the law of cosines to find one of the angles. So the first one we're going to find, let's just pick angle A. So the cosine of that angle is equal to b squared plus c squared minus a squared over 2bc. So we simply plug in the numbers and we get 0.75. So then we do the inverse cosine and we get the angle A is 41.4 degrees. Okay, then we're going to plug in using the sine. The law of sines is easier because it's so much simpler. So then we're going to do the sine of C over C is the sine of A over A. So now that we got that one angle, we can use it. So then we're going to get the sine of C is equal to 0.8266. Now notice this. It says angle C is not the largest angle, so it's acute. So we're going to need that because when you do the inverse here of 0.8266, you're going to get this, but you don't know if you add 90 or not. So we have A and we have C. Then we're going to use A plus B plus C equals 180. So you can find B by substitution, which is 82.8. We know the 3 sides as they were given. And now we know the 3 angles through the law of cosines, the law of sines, and then the 180 degree rule. Okay, let's do another one. Okay, example 2. We have side, angle, side case. Now in side, angle, side, remember, the angle has to be between 2 of the sides. Otherwise it's not side, angle, side. So, solve the triangle ABC if A is 8, C is 7, and B is 31.8. Okay, well, we're going to find the third side first using the law of cosines. B squared equals A squared plus C squared minus 2AC times the cosine of B. That was the rearranged version to find the side. We plug everything in. We get B squared equals 17.8, square root at 4.2. So B is equal to 4.2. Now, use the law of sines to find the measurement of angle C, which is the smaller of the 2 remaining angles. The sine of C over C is the sine of B over B. Plug in your numbers, and you get the sine of C is 0.8783. Inverse sine, and you get 61.4 degrees. Use the 180 degree rule to find A, and again, we're done. You got all 3 angles and all 3 sides. Okay, now in this next case, it's the side-side angle case, and it's often called the ambiguous case because there are 6 possible outcomes. If angle A is acute, there are 4 possibilities. If angle A is right, or obtuse, there are 2 possibilities. So 6 total possibilities with the side-side angle case. Here they are. Now suppose that angle A is less than 90 degrees. Okay, so this is situation 1. Angle A less than 90 degrees. Now, if A, the side A, is shorter than B times the sine of A, which is the height of the triangle here, there is no solution because it doesn't reach. Now, if A, the side A, is equal to B times the sine of A, then there is one answer and it's a right triangle. If A is bigger than B times the sine of A, but less than the side B, there's 2 possibilities. It could be an obtuse angle here or an acute angle out here. Okay, and if A is bigger than B or equal to it, then there's only one possibility. Okay, now suppose that A is bigger than 90 degrees, the angle. Well, if A is bigger than 90 degrees and A is less than B, it never touches, and so there's no solution. If A is bigger than B, then there's one solution and it touches right there. Okay, so let's look at this case and see if any of that makes sense. Here's a side-side angle case. So here's our triangle, ABC. Now B is 22, C is 30, and angle B is 30 degrees. Let's use the law of sines to get us our angle C. So the sine of C is equal to the sine of B over B. The sine of C is equal to C times the sine of B over B. See how we multiplied here. So 30 times the sine of 30 degrees equals 22. Substitute, the sine of C is this. Now, angle C is equal to 43 degrees or 137 degrees. Could be acute, could be obtuse. So find angle A by using the 180 degree rule, either 107 or 13. Then use the law of sines to figure out what A is, and it's either 42.1 or 9.90. So there's 2 possible triangles with this side-side angle case. It's not, this information is not enough to let you know which triangle it is. There could be this triangle or this triangle. Okay, let's look at another one. This one's an angle-angle side case. Here's the triangle, ABC. They give you a side and then 2 angles. Now you can find the 3rd angle right away. Then you can use the law of sines, substitute, and find the sides. Okay, not too bad. That's it. Let me know if you have any questions and just start working through them. Thanks.